Hello, everyone, and thanks for joining me again today for another session of Me Programming Daily. Let me just transition to the code view. I hope you're having a drink of choice ready. I got myself a nice piece of cup of coffee. So yesterday, or during the last session, whenever you watched it, I worked on these conditions that would help us detect loopback conflicts. We have some unit tests ready. Well, actually, lots of them. And I believe this needs to be fleshed out / corrected a little bit before we can declare full victory. So first of all, we need to do something with these connections. So they're only partially right. So what I mean is the y1 coordinate is the coordinate of the second connection that we're going just to draw. And what I realized is that the types are organized in such a way that y1 prime will always be lower than y1, which is the y coordinate of this point. There's just no other way. So I'm going to delete these conditions, and we are left only with y1, y2 prime equals to y1, which is going to be this. This is not only not a collision, it's an illegal state. So we only really should worry about this state where y2 prime, which is the y coordinate of this point, is equal to the y coordinate of this point. If they are equal, then we just need to compare the x coordinates. But let's take a look. Question mark. But let's take a look at this. So if y1 prime is lower than y1, which is probably always going to be the case, and when y2 prime is greater than y2, so we can just do something like this. Well, technically, this will always be right. So we can just combine this first condition, y2 prime equals y2, with the second, and use greater or equal than. This will always be true, except for unit tests, but let's not worry about those. If y2 prime is greater or equal than y2 prime, the collision is going to exist if x2 or x equals x1 or x2. So let's go with x2. So if they are equal, it's going to be a clash. So again, let's recap. In this scenario, both y1 prime and y2. So technically this is an illegal state. It will never happen. But it's good to have it, I think. So both y1 prime and y2 prime are above here somewhere. Let's leave it just for the sake of it. Or you know what? Technically, it should be an illegal state. So let's remove it. It is an illegal state. So we only allow for a scenario where the second connection is going to be underneath the first one, or the second connection is going to be overlapping on the third point or higher. So only in these situations we need to check for X. And every other scenario, let's think about it. Every other scenario is not only not true or false, it's just an illegal state. Sorry. So else. So we don't really have that many options here. Either the second connection could be underneath the first connection, or the second connection could be overlapping like this, or it could lead to the same y2. Everything else is an illegal state. So I have my ideas for representing illegal state, but for now let's just leave it to do here. And we should create an issue to represent a legal state. So here, if x equals x2, then it is a clash, or collision, or conflict, else false. And I know it's pretty general to assume that in this scenario every state is illegal. We'll see how it works out in practice, but I believe this should be more or less correct. Let's see if unit tests got affected. They did. 189. Okay, non-overlapping loopback connection 1. We return false. And true, we only return in a very specific scenario. Okay. Now, let's see what we have here. Non-overlapping existing loopback 1. We only care about these 2 points. See, so this has not much to do with reality. This is the same point, but let's entertain it. So in our case, y2 prime is always going to be lower than y1 and y2. It is lower. Y1 prime is, this is 1 and this is 0, so this is going to be false. We'll go here. Y2 prime is lower than y2, so false. Let's just quickly test it. We crash in 189. Same thing. Let's be more careful this time. Have 1 1 0 0. So in our case, it's 1 is so that's false. So the whole condition is going to be false. Then y2 prime is greater or equal than y2. It is. And x equals to x2. So our x is 1 and x2 is also 1. So it is an overlap. Okay, so that's fine. Let's just quickly rename it. And that is true. Let's see where it fails now. 191. So yes, because x is equal, x1 and x2 are equal to rx. But that's fine, we can leverage that as overlapping existing loopback 5. And this, we can simply change to x plus 0, 1. So this will not overlap And we're just going to add another test here. So I appreciate this is taking a lot of time to come up with these conditions and with unit tests for them. But I think it's fair, and I'm not in a hurry to rush it. And everything passes. Beautiful. Okay. What I believe we should do now is to start incorporating this logic. We don't need this. Start incorporating this logic in a scan across the entire collection of loopback connections. So let's just start with a very naive fold. You know what? Let's leave the head in place. And let's see what happens. So we'll change the bubble sort. Let's get rid of QWE1 just to make it more compact. Action 1 can stay. Okay, that is more compact. Let's get rid of QWE2. Now, let's introduce question 3. And in question 3, let's link to maybe something else. Let's shift everything. 1, 2, 3. Action 2. Right, yeah, let's give them identifiers. Question 3. Or just no identifiers in the name. This links to 3. This links to 2. And this links to 1. Yes. So if we didn't have this, the overlap here wouldn't exist. Like this. Let's see, last. Okay, so we need to check all of them here. Okay, so that's just, it was an interesting test. Yeah, so we need to go with some sort of a loop. Just do a fold. So let's assume that we're returning true in all scenarios. Oh yeah. Oh, I see what's happening. So the problem we're facing is because of this. We only ever add like a fixed offset, but the offset should depend on how many collisions we detected and how much we need to shift to the right. So in order to simplify this whole process of comparison and in order not to execute this check multiple times, this collection should be sorted by the x-coordinate of every second point in each of these loopback connections, from lowest to highest. Okay, but for now, let's not worry too much about it. Hold on. I think they are going to be sorted automatically. Because if there is a collision, it means that x's are equal. Okay, let's see. So technically, this should not return a ball, but instead a double. And that double should be a shift. If there's a conflict, 0, 1. Else, 0, 0. So this is still not going to produce correct results. Oops. Okay. So we are going in the right direction. Oh, let's leave that to do for now. But there's still some more stuff to do. Let's see how Ormolu formats this. Or H-lint, right. Or H-lint, yeah, probably Ormolu. Okay. Let's maybe change this a little bit. Now this is interesting. I know this is kind of pointless, but still want to experiment. So these two are fine, seemingly, but the first one isn't. Ooh. Oh, 0. That's not correct. Okay. So we are slowly getting places, but the last loopback connection is still not correct. Let's test it. Oh. Oh. We don't need this here. That's the wrong function. I was a bit too eager. All right. So maybe, as our time is running out slowly today, let's just add a couple more test cases to this. And let's see where we land. We have overlapping existing loopback. So let's make it something more predictable and closer to life. Let's go with 0, 0, second point 0, 1, third point 1, 1, and fourth point finally 0, 1. X. Oh. Oh, that is supposed to be a list of lists. So let's provide something like this. X, X, thank you. But got 1.1. Oh, now we need a list consisting of 2 loopback connections. All right. So we are getting a consistent shift after shift. So there must be some problem with our rendering. Is that right? Okay, this looks like a challenge for another session. For now, I'm pretty happy with the progress, albeit it's snail paced. But still, we provided some new unit tests, refactored the code. We provided some conditions for all loopback connections. Should it be fault R? Because this is not how the collection will look like. Let's do fault L still. See, these shifted connections will go at the front of the list. And now it will fail. So let's do fault R. And now it should pass. Okay, so let's run it. And if this doesn't produce expected results, meaning no overlapping loopback connections, means we have a deeper problem. But it does. Okay, so let's add more of these. Let's number them in a reversed order. One, two, three, four, five. There's no reason why it shouldn't work, but we'll see. 2, 3, and the last one is 8. Okay, so let's maybe go to 10. One, 2, 3, 4, 5. 2, 3. Oh, this is looking nice. Hard to read, but no overlaps. I'm liking this. Cool. Hard to read, but not because there's ambiguity in the chart, but because it's just a large chart or large diagram. Very happy with this. Okay, I think we're going to draw the line today for any more changes. I'm not sure what I'm going to be doing in the upcoming sessions. Probably we're going to go back to the issues we encountered while trying to implement the bubble sort. And I'll PR this later on. Yeah, and we'll see where wyvern takes us. So I would like to thank you all for your attention today. Have a great day ahead, and I'll see you next time. Take care. Bye.